So for this section, we're continuing the modeling functions using some contextual applications. So we're going to continue to look at our work in the pumpkin pie bakery as our contextual framing for this concept. So we have Janelle and Hector working at this pumpkin pie bakery as pie makers. Janelle can make 10 pies per hour in 2 hours. And Hector can make 9 pies in 3 hours. Okay, assume the rates are constant. So what they're saying is that we can come up with a rate that applies hour after hour after hour. And it says how much profit do they bring to the bakery. So we're looking at the pies that they can make. And so this first question is, how many pies can Janelle and Hector make together in 1 hour? So we are looking at this in terms of 1 hour, that finding their rate. The rate of pie making per hour. So we know that Janelle she makes 10 pies. 10 pies in 2 hours, and so that is 5 pies per hour. And or we could write it like, maybe we should just do this, 5 pies per hour, like that, like a rate. And then we know Hector can do 3 pies in 3 hours, and so Hector makes not 3 pies, 9 pies in 3 hours, and so Hector makes 3 pies per hour. So that's their hourly rates, and since those are over the same time period, then we know that we can just add those together to get the number of pies made in an hour. So the number of pies, maybe we just call that n. The number of pies then that they can make is going to be 3 plus or 5 plus 3. I'll do them in the same order that I figured them out initially. So 5 from Janelle and 3 from Hector in an hour. And so we are talking about 8 pies per hour that they can make together. And so we can use that rate then to get a generic expression, or a general function, so to speak, of how many pies they can make total. So it says how many pies can Janelle and Hector make together in T hours. So we can generalize that expression then to say, well, we know that the total number of pies in T hours is going to be the rate, which is 8 times T. And that is what we can use then to find their how many total pies they can make over the course of a day or a month or a year, as long as we know how many hours they work together. So we can kind of use that then. We're going to use that function, and we're going to kind of continue to extend this storyline, or this contextual application. And so in number 2, it says, recall that the amount of profit that the bakery earns each day depends upon the number of pies made. And if you remember back from the previous lesson, we had a profit function of 15.5n minus 85, right? We talked about the profits on the pies and the overhead costs that they had to consider. And so this goes on to say, if Janelle and Hector make 20 pies, how much profit will the bakery earn? So we can use that profit function and find the profit for 20 pies by just substituting in the 20. So 15.5 times 20 pies minus 85 is what the profit equals. And so our profit for 20 pies is going to be $225. if we do 15.5 times 20 minus 85, we get $225 of profit. So so we know the profit they can make in 20 hours. Or excuse me, the profit they can make with 20 pies. So the storyline goes on. It says, last Saturday, Janelle and Hector worked together for 5 hours. How many pies could they have made during that shift? So going back to that pie function from number 1, we know that the number of pies that they can make together is 8t. And so if they are going to spend 5 hours making pies, then the number of pies they can make is 8 times 5, which is 40 pies. And then they go on to ask, how much profit would that have made the bakery? So the idea is, well, now that we know how many pies they made, we can use that profit function, and that because that profit function is based on the number of pies. So if you look at the variables we're using, you can see where we start with we started with a time concept, and it's going to get us all the way to money, right? So the profit is based on the number of pies. I'm going to grab that profit function now from number 2. 15.5 times 40, because they made 40 pies in those 5 hours, minus 85 is going to get us $535. So that's what they made in 5 hours at the bakery. But really what we're doing is we're saying we're making this kind of a 2-step process here. So if we look at this, we started with time, right? 5 hours. And that got us to pies that we made in that time, which got us to profit. And maybe I should make this number of pies, right? This is N, and that got us to profit, which is P, through the course of those 2 functions. And really what we could do is, if we knew how long they worked, we could make a composition of functions that gets us right from time to profit. And so the way we do that is we take this function and put it right into our profit function. So in other words, we take the number of pie function, so the number of pies for 5 hours, and we put it right into the profit function. And that we can get, and then we can get that $535 directly, just based on the time, the 5 hours. And so what we're gonna do is we're gonna kind of map that out down here in this chart. So the manager of the bakery is trying to decide how many hours to schedule Janelle and Hector to work based on the desired amount of profit. Complete the table below to help determine the profit based on the number of hours worked. So we have, so this is our 2-step process that I was kind of describing here. It's right here. And so we've got the number of pies. So we know the number of pies here is going to be 8 times the hours worked. And we know the profit is going to be, whoops, what was profit? Profit was purple. Let me get the right color there. We know the profit, which is based on the number of pies they make. So that profit is based on the number of pies they make. Okay, is going to be putting in the value of, or the number of pies into that equation. So that's going to be, let me move that over a little bit. A little space right. That's going to be the 15.5 n minus 85. Okay, so we've got, let's see, they work 3 hours. So if they work 3 hours, we've got 8 times 3, which is 24 pies. And then the profit is going to be 15.5 times that 24 minus 85, which is $287. Okay, how about if they work 6.5 hours? Well, 8 times 6.5 is 52 pies. They're going to make 52 pies over that time. And so their profit now is going to be 15.5 times 52 minus 85, which is going to be $721. And if they work maybe pretty much a full day here, 8.25 hours, then the number of pies they make is 8 times 8.25, which is 66 pies. And then their profit off of 66 pies equals 15.5 times 66 minus 85, which is going to be $958 in profit. Okay, then it goes on to say, write an expression the manager can use for determining the amount of profit earned based on the number of hours they work. So this is kind of what I was alluding to back in number 3. We really would like to have that profit expression. Let me come back up here. This profit expression based on time, right? Based on like 5 hours of time. And so we can build this composite then, where we just say, okay, we don't really want to count the number of pies made. We just want to say, hey, we're going to schedule the 2 of you for 7 hours. What's the profit going to be? We don't really want to count the pies and have to take on that middle step. So that profit then is going to be taking the number of pies function, so the number of pies function, and sticking it right into that profit expression. And so that's going to look like that profit equation. If you remember, it's that purple highlight right here. It's 15.5 times the number of pies minus 85. And so now it's 15.5 times the number of pies, but the number of pies is a function itself. It's 8 times t. So it's 15.5 times 8 times t, and then minus 85 for that profit function. And that profit function is now a function of time. And we could simplify that. We could just say P of t is 15.5 times 8, which is 124. So this is 124t minus 85. And now we have a profit function that is just time-based. So now, instead of having to count pies every day to put it into a function that has the number of pies as the independent variable, now we can just say, let's just schedule these people for a certain amount of time. This is kind of messy. I'm going to clean that up. There we go. And we can find the profit directly from that expression. So now it says, one day the manager forgot to write down Janelle and Hector's hours. She does know that the bakery made $411 in profit that day. So now we can use that function and work backwards and find how much time was spent making the pies. So we know that they made $411 in profit, and so that's going to equal 124 times t minus 85. And then we can figure out how much time was spent in the bakery. So we can just add 85 to both sides. And then we have 496 equals 124t. And if we divide by 124, we get t of looks like 4 hours. So both of them spent 4 hours in the bakery baking pies. So looking at this, what we're really focused on here is coming up with that composite expression, like right here and right here, putting one equation into the other so that we can have this composite expression and kind of skip the middle step. And in this case, skipping that middle step of finding the pies when all we were really concerned about was making the profit here. So as far as the quick notes go, the learning target number one, here is creating a composition of functions. So composition of functions. So what we're getting at here is given two functions, we can write a composition of functions. So here's the notation for that. So like I said, just a second ago, it's saying we can put one function into another. So look at this notation. We want to put the number of pies into the profit function. So it says given two functions. So if we have two functions, f of x and g of x, we can create a composite like we can create a composite like this, and that is saying that we are going to put g of x into f of x wherever we see an x. Or we could flip-flop that. We could write this composite, and that is saying we can put f of x into g of x and simplify that and come up with a composite function. We do have another learning target, and hopefully I've got the space for it. So let me just shrink that down a wee bit. There we go. Okay, so the other learning target, come on. There we go. The other learning target 2, says how do you evaluate this? So the nice thing is there's kind of two ways of evaluating a composition. So this is the evaluating part. And if we look back at evaluating a composition, if we look back at the notes, we can evaluate it two ways. We can take it in two steps, kind of like we were doing up here, right? We found the number of pies, then we took the number of pies and put it into the profit expression. So we started with time. I kind of mapped it out here, right? We started with time, put it into the number of pies function, right? Got the number of pies, then came down here and put that into the profit function and got the profit. Or we could find the profit directly, just by directly substituting time into, and that would be this, right? Substituting time, making the composite, and then substituting the original variable into the equation. So we can evaluate the composition those two ways. We can say, in this case, we plugged the time to get the number of pies, and then the number of pies to get the total profit. So if we are looking at, I'm trying to think of some generic way of saying this. So if we wanted to evaluate let's just pick one of those expressions, f of g of x, then we can plug in a number for x. Okay, so using this expression here, we can plug in a value for x. Let's call it c. So we can plug value of c into g of x, and that will get us g of c. And then we take g of c then, and then we plug, actually let me restate that, then we can plug g of c into f of x to get f of c, okay, and or to get f of g of c would be a better way of saying that. So we can do that. That's that two-step process. We can do it that way, or we can find f of g of x simplified, right? We can just find the composite, or the composition of the two functions, and then plug in value c to get f of g of c. So there's kind of two different ways to evaluate to get the answer. Just a matter of, do you want to work numerically and do two steps, or would you rather find the new function and then plug in the value to get the numeric answer? So that's what you're going to be practicing here with these checking your understanding questions. You're going to be practicing substituting in and working with that composite notation, substituting in values or substituting in variables, and just coming up with that composite function. So just to kind of check your work, we do have the full solutions in Blackboard. They're linked right with this video, so you can go to the PDF and check your answers. But just to give you an idea as to whether or not you're on the right track, the answer here should be 507. I'm not going to give you the two answers for B and C. I would rather you check those in Blackboard on your own, because those are going to be algebraic. And the answer down here is 589. So just to kind of give you an idea.